When a direct current is passed through water containing a conducting salt, water is decomposed at the electrodes. Hydrogen is generated at the negative electrode, and oxygen is generated at the positive electrode. When the electrolysis has proceeded for a time, we note that the volume of hydrogen gas formed is twice that of oxygen. Since the volumes of gases under identical conditions are proportional to the numbers of molecules present, this tells us that there are 2 atoms of hydrogen in the water molecule for each atom of oxygen.
This is what?
This is the Hoffman apparatus.
And it's used to
produce hydrogen and oxygen from water. All you got to do is fill it with water.
That's just regular water, right?
Well, actually, water with a little citric acid, potassium hydroxide, anything like that. The more conductive you make the water, the faster hydrogen will come out.
And each one of these sides is supposed to be hydrogen and oxygen?
Right. One will be hydrogen will bubble up out of one, and oxygen will bubble up out of the other. Remember, water is H2O.
Right.
So when we break the bond of water apart, we'll get twice as much hydrogen gas as we do oxygen.
So each one of these tubes, the water just goes down, but what's left is the gas?
Right.
And there'll be more on this side?
Yes.
That's the hydrogen side.
Exactly. And that's the negative.
Oh, so it matters which way you hook these up. So you got to hook up positive to what is, the positive's going to make... The
positive will make the oxygen, and the negative will make the hydrogen.
Okay.
So we've just connected it there.
Right.
And just by turning it on, you can see bubbles start pouring up out of there.
It's 7-Up.
Kinda.
So those bubbles are, well, they're not the same. So these are hydrogen bubbles and those are oxygen bubbles.
Right. And what we'll do is take a little sample of the hydrogen gas and light it.
Right.
And you can see that.
What are these? You just have electrical current going to a piece of foil?
Well, it's a piece of platinum foil, and the reason you need platinum in there is because it's very corrosive to a metal for electrolysis to occur, but platinum is highly resistant to corrosion.
See this nice little stove here? That was a propane stove. Can be a propane stove, still operates as a propane stove, but right now is burning the gas that we have gasified and produced. Now, of course, you might ask me, how are you storing the gas and everything? And it went right into a balloon. No pumps, no pressurizing needed, but latex weather balloon, it's already been running the stove for a long time, hours. And just a simple little valve of any type will work. And going through straight airline hose directly up to the underside of the burner. But this is an off-the-shelf propane stove that we quickly modified on a temporary or permanent basis over to be a cooking stove. And you can cook anything you want on this. Yeah, pretty, pretty, pretty blue flame. And if you want an idea of what's really possible, there it is dumping through the 1/4-inch tube. Black iron 1/4-inch. I've dumped this through 1-inchers like this that are metal, and it's like Terminator blowtorch. So this can be a lot of power. That right there, it's about enough gas to run a 1 or 2 kilowatt generator. That is actually a lot more than it looks. See, so you can get a reference of the size. That's about an 18-inch flame. And you can see the balloon's just really not shrinking real quickly. Look how pretty blue that is. See? Actually, I make gas from this too. It's coal. And there's the balloon. This is quite small. It can be a lot bigger than that. No, I'm not going to pop the balloon in the lab with the flame. Don't ask. Maybe I'll do that later outside. Thank you.
Running on faucet water pressure for this demonstration. Okay, let me just get things fired up here. Okay, as we can see, it's It's able to go around quite readily. You can rev it up, it's quite smooth and relatively smooth. A bit of vibration there. Okay, that's it. Full RPM there now. Moves along quite nicely. Now the beauty of this setup is it's not even attached. The turbine's going around here, and I can shut down the turbine, hook this back on, and turn on the turbine, and away it goes. All magnetically driven. Okay. Now I just want to show the other shake flashlights in place here.
Here you can see the setup for an active water distillation system. Reason why this is good is because in the times that are coming, there's going to be lots of earthquakes and dams are going to break. There's not going to be any fresh water, and so this is a very quick way to take salt water, ocean water, brackish, swampy water, polluted water, you name it, just really bad water. You can put it in a pressure cooker, connect the tubing to it, like silicone tubing that you can get at the pet store, or neoprene tubing that you can get at automotive stores, and secure it to the pressure cooker. And there's a variety of ways of doing that. And then run it through a bucket of cold water.